Hey guys, this is Mr. Pasco with another video of network mathematics. This time we're looking at planar graphs. So we're looking at removing intersections, actually, where things cross over and you can have car crashes at crossroads. We're looking at trying to change the graph or the shape so that we don't have those sort of intersections and crossovers in it. So planar graphs are basically networks which don't have any crisscross type intersections. Now, there is a mathematical rule that you can apply to planar graphs called Euler's rule, but we're going to look at that, and I think I've spelt it incorrectly there, actually, on that slide. I think it's E-U-L-E-R-S. Anyway, that guy's rule, we'll look at that in a separate video in the next lesson. But okay, so in some cases, you'll have a graph. So we've got A connecting up to B, C, and D, and B, D have a direct connection, and A going across to C has a connection here. But we've got this crisscross in the middle. Now we can redraw that and still have everything in the same position and have the same connections, okay? So there it's got the crisscross intersection, but we redraw it like this, A, B, C. Now we've still got the BD line, but what we do with the AC line is we just make it take a longer path. So to get from A to C, it's just going to go around the outside in a big long kind of arc or circular path here, part of a circle. So that's how we change this now, so that is now a planar graph. We don't have any kind of X's or crisscrosses in it at all, okay? So that would, by doing that, you could reduce the number of vehicle accidents you have, like when two roads meet and cross each other. And you don't usually have train lines doing that because trains are very big and heavy and they can't stop easily. And if two trains smash into each other, that'd be really bad. But removing train level crossings, which they're doing at the moment in Victoria here at Melbourne, that is reducing the chance of trains colliding with both people and cars. So, all right, so there's an example of where they're making the network more planar. They're making the rail network more planar so that it does not intersect with where the cars are going. All right, so there we go, some networks in the real world. Planar networks, planar graphs. Now, here's your typical example. Redraw the graph so that it has no intersecting edges. Looks like I forgot to put animation on this slide. But anyway, there's the original graph, and you can see, yeah, we've got crisscrosses with E going to C and B going to D here. So we've got a big X there, and we've got another big X here where there's a crisscross. So the first thing to do is to list all the connections you've got in the original path, because you've got to make sure when you redraw the thing at the end, you've still got all the same connections. So I've got AB, AF, BD, BE, C to D, C to E, and D to F. And we'll take the book's word for that, that's all correct. It looks correct when we check it out against the drawing. So the first thing is to draw any sections. Are there some sections without crisscrosses that would be fine to use? And we can see we can have F to D and D to C, this bottom part. We can have that part okay, because there's definitely going to be no crisscrossing there. And we can keep this top part, E to B to A. Okay, that's all right, but when we start doing this A to F, we get one of those X's, those intersections, those crossings, so that's so good. So anyway, you can keep this part of the graph. Now let's cross off the connections we've got. They're all the ones we have to have. Now we've just taken care of AB, so we can cross that off. BE, we've got that okay, so we can cross that off. We've got CD, cross it off, and we've got D going to F here, so we can cross that off. So we're just going to worry about now with this modified diagram, how can we connect up A to F, B to D, and C to E? All right, so step 3, draw any further edges that don't create intersections. Well, a way we can get from A to F is quite easy. We could still keep this line here that goes from A across to F. So we can do A to F that way, and let's cross it off. We can do B to D. B to D, you can just go straight down here and still connect B to D and not have any crossover, so that's good. And to do the C to E, what you do is instead of C to E going here and making a big mess of the whole drawing, going right through the diagram and making the two X's, we just do a big loop around the outside like this. And now we've got a planar graph. We've got the exact same points. They've got the exact same connections. You've got the same number of vertexes. Things are still the same degree. Remember, degree is how many lines are coming out of the vertex. So at B, we've still got 1, 2, 3 sticks coming out. And in the original one up here on the left, we've had 1, 2, 3 edges or sticks coming out there. So that's all the same and that's all good. And that's what we're doing when we're making a planar graph. And apologies for not remembering to animate this slide, but hopefully the other ones are going to come out animated unless I'm running the wrong version of the PowerPoint here, which is quite possible. All right, we have animations at last. All right, now not all graphs can be arranged to become planar, so not everything that's got crisscrosses and X's in it can be rearranged. So a star network can be rearranged into a circle or a pentagon. You just follow the lines that were drawn freehand to draw the star to work this out. Okay, so here's a star, and if you haven't drawn one of these, if we're starting at A, we need to go A across to C, then you swing your pen down to E, then you go up to B, then down to D, and back to A where you started. So we're going A, C, C to E, E up to B, B down to D, and D to A. So basically, that will come out as a pentagon if we just say, okay, we're going A to C, we're going there once, and then we're going from A to C, then we go down from C to E, so let's go C to E, then E has to go up to B, so E's going to B, B's going to D, and D, when we're down the bottom here, is where we come back up to A to finish the star. So that can be laid out here in a planar network, which is a pentagon, or if you wanted to be fancier and try and draw a circle around those points or an oval shape, that would be the exact same kind of answer as well. So often there's two answers for making the network planar. It's not just one answer, but the answer you have can't have any of those X crisscrosses. See, the star's got lots of them there. An X there, there's an X there, there's an X there. There's all these intersection crisscrosses, but that could actually be rearranged into a planar graph. But if we take that star, and this is a fairly famous example in networks, if you take the star and then you draw a wobbly pentagon around the outside, so all of the pointy bits of the star, just connect all those pointy bits up with lines, well, you can sit there from now until the end of time, actually, trying to separate that and break it up so it doesn't have any X crisscrossing, and you'll never be able to do it, okay? So that is one of the classic shapes, the star, with a pentagon drawn around it, or you could kind of make those a bit more circular if you wanted to, but if you connect up all the points of the star as well, then you'll never be able to untangle that kind of web there to get it into a planar graph. So that one cannot be a planar. So not everything can become a planar graph. Here's a typical question from the exercises we're covering in this video. Exercise 5.3, we've got this graph here, and you can see you've got A, C, E, D, B, and we've got an X there, an intersection. We've got one here as well, so we need to get rid of that. Now, we're going to talk about this later, but some of you that kind of think origami style or have good 3D visualization, I do not have that, and I really struggle with doing these sorts of things. I'll just show you this quickly, and then we'll show you the other answer, if this all works properly. So let's just grab a pen. We could keep the A, B, D, E, A thing on the bottom. And you can think of this bit here as sort of sticking up in the air like a folded triangle. So there's a flat piece of paper. And then along this line here, we've kind of folded it origami style to fold over this triangle. Okay, so we're kind of making some origami thing. So what we're going to do is we're going to fold that triangle back out this way and make it all flat again. All right, so what would happen was C would just move over to here. All right, and then you've got a planar network. So that one involved moving this vertex from where it is here, sort of over to here, and then sort of flipping the piece of paper back down. That was supposed to be a C and not a very good one. All right, so that is a way to do it, but that's not the way we're going to look at it right now. But some of you may have spotted that straight away and think, well, why isn't he doing it that way? That's so obvious. So if you've got good 3D spatial recognition or whatever, you might do it that way. But let's get back to pointer options. Okay, how do I get off this one? I always get so messed up with these. Oh, general shortcuts. All right, so let's try. So the ABDE connections are okay, as we're talking about. The ones on the bottom are okay, and now I've got an eraser as a pointer. I don't know how I've done that. Pointer options. This should be able to just make it into a pointer. Arrow options. Oh, let's try automatic. Oh, We did it. All right, so we could leave that bottom part as we were talking about, and the C's sort of over here at the moment, okay? And we're leaving the C in that position. And what we're going to do is, instead of having sort of A crisscrossing to reach C and that, we're just going to make A go around the long way to C like this in a curved path, and then to get the C to E part, which we had back in the original direction. So we got the A to C and we need a C to E. We're just going to go from C to E round the long loopy path like that. So that is another planar version of that network, all right? So definitely that diagram, it's been badly drawn there, and it's not drawn as planar because we've got these X crossover points, but we can redraw it, fold it out origami style, or just pull those connectors off and turn them into round connectors. Or think of this as a rubber band, and we're just stretching out that AC to make it go over here, and we're stretching out that CE to make it go down the bottom here to make this shape. All right, so that is a planar network, even though it didn't look like one right there. All right, so let's have a look at another one. Now, this one looks horrible and complicated when you look at it, but there's a little kind of shortcut trick. And another shortcut trick I forgot to tell you is I'm a slow talker, and I'm very slow with those pens, as you notice. So best to hit the player bar in YouTube, click on that tools cog, that round cog, and change the play speed up to 1.5, 1.75, even 2 times play speed, because I'm really slow and this video will seem really long and horrible unless you do that, all right? So I suggest increasing the play speed. So here we go. This looks really bad, but if we have a close look at it, the thing that's causing all the trouble is this B to C connection. Everything else is okay, actually. It's just this B to C. As soon as we draw in that B to C connection, bang, 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 bang. We've made 4 intersections there, 4 X's, and that's bad. So let's just remove that B to C connector using some magic from Photoshop, the eraser, when you copy it in, and that's what we've got left. So we need to figure out how can we connect up B to C without crisscrossing and ruining our shape. And the way to do it is either do a long curved line up the top here to connect B to C instead of just going through everything in a straight line. Do it in a curved line, take the long way around, or you could do it down the bottom ways. You could take from C down the bottom, have a curved line to B. So it doesn't matter if you make this top one and make a mushroom, or if you do it up the other way. Either way is okay, and that's going to make it now into a planar graph. All right, so this original guy was a planar graph. It just has been drawn badly, or it's been twisted up and tangled, if you like. And here's where we untangle it all and we make it into the planar graph that it really is. So these sort of things you either really like or you really don't like. It actually takes me a long time to do some of these. I'm not really great with spatial recognition, but let's have a go. But there's sort of rules you can follow. So you can see here that the things causing the problems are the AE and the DC. That's what's making that cross in the middle. And also DE is a problem because that's crossing over these 2 lines. So they're the troublemakers. So the way I approach these problems is I say, let's get rid of the troublemakers first and then figure out another way to connect them together. So what we're going to do is we're just going to take away AE, CD, and DE. And you can see we've done that here through the magic of Photoshop and the paint tool. Actually, I was painting over the lines to do that. All right, and we're going to have some squiggly wiggly connections to get it all sorted. So we need to have A connecting to E, so we can do a big round sort of path here going A to E, and we've taken care of that. Back in the original one, we needed D to E. How we're going to do D to E is we're just going to go from D here, down the bottom, curve around, miss B, and come up to E. So that's this kind of one. It's kind of like that. And the way we're going to get that last one, DC, is a bit sneaky. What we're going to do is we're going to come down from C and we're going to sneak past through that gap so that we don't touch E and don't do any crossovers, and then come around here and up to D. So that's kind of your D to C line, a very long wiggly line. And then we had to do that as a skinny one in the inside. Then we could fit in DE, and then we could fit in AE. So all of those don't have any X crossovers in them, so that is a planar graph. And look, there's probably other ways of doing it as well, and that's fine if you do find another way. The main thing is that you're not allowed to have those X-shaped crossovers. All right, now this one, this is a real kind of interesting one. Look at how many X's there are in that. And this is where you want to sort of just close the book and call it quits. And look, the first time I did these, that's exactly how I felt. I thought this stuff is horrible. It's really making me feel bad. But look, there is a way of working it out. C, D, and B, E. So again, I look for the troublemakers because C's crossing over 1, 2, 3 there, and B's crossing over 1, 2, 3, 4 things. So C and B, E, and C, D look like the troublemakers. So I'm just going to remove those out. This is kind of the passive method of doing things. And then we're left with this kind of setup here. But we need to somehow do C, D, and B, E connections. But this one we run into a problem because of where B and C are located, all right? And what happens is there's no way to kind of do these outside big loopy ones. That's our usual trick, to then fix it up so it's planar, because we'll always get some crossover between the loopy ones, all right? So it looks as though, no, can't do this, it's not planar. Well, it actually is planar because we've been doing it by a method of just leaving the letters, the vertices, stuck where they are on the page, but you are actually allowed to move the vertices around to make your planar graph, okay? So there is a way of doing this, but it's obviously not the usual passive way of getting rid of the troublemakers and then trying to do big curvy lines around the outside. That works sometimes, but it didn't work on this one. Boo-hoo-hoo, I'm crying, but there is another way of doing it. What we're going to do is, the whole trouble is C's over here before B on this side. So that's our troublemaker there now, G to C. So what we're going to do is, we're just going to pop C, move it from there, where it is, over to here. Okay, so we're just redrawing that line. Instead of sticking out to the left, it's sticking out to the right. And that will make the world of difference, because now we can do BE around this way, and to get that CD connection that was crossing over before, we can just do it as a straight line here. I've just done a little curve, but that could even be a straight line and a triangle for that bit. All right, so now we've got a planar graph without any of those X crossovers. But you might be saying, oh, but there's giant crossovers here in G. No, it's not actually any X crossovers because they're not going out the other side. Okay, G is just a vertex here that's got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 edges coming out. So that would be degree 6. Remember, the degree is how many edges come out of the vertex. That's just a high degree vertex with 6 things coming out of it, but it's not a crossroad, okay? It's not an X shape. So that's a planar graph. That's all good. Now, there is another way of moving them as well, which you might see as the answer in some textbooks or worksheets you're doing. We can move both C and E, all right? So we're not just going to move C from its spot here. We're going to move E as well. And we're going to kind of flip C over to this side. So we just make it do a 180 flip. And we're going to flip E from down here up to here, okay? So you can move both of them. So we've just flipped C from where it was on the left down to the right, and E was down the bottom on the left, and we put it up the top on the right. And then we can connect together our B, E, and C, D, those two problem connections we had, as triangles with straight lines. Mine aren't too straight because I'm not a great drawer, but that is another way of drawing the planar graph. And it's the exact same graph. Like if you check the degrees, G's still got 1, 2, 3, 4, 5, 6 coming out of it. A's still got 2. And if you go all the way back to the original one, all the connectors, all the connections, the number of connections coming out of each vertex, the degree, they should all match up and be the same, and they are. So there's often different ways, more than one way of making a planar drawing of some sort of horrible tangled up graph that's been drawn badly. Okay, so there were a certain set of network connectors. Someone just drew it bad, so there was a lot of crossovers and X shapes in it. Now, some of these can get quite challenging. And this is the sort of one that I really do not like myself. But sometimes there's little tricks. Like, remember, if you can remember back to that star, remember how the star came out into a circle? Because we were able to trace round, and every vertex only connects once to every other vertex. Now, if we start at A here and start tracing round, you can see we go from A round to E, then we go up to B, down to F, up to C, down to D, then we go up to G and back to A. So we're just kind of doing a continuous path here where we're not kind of visiting any of those vertexes twice. And this is going to be talked about in later lessons actually. That's a special characteristic of that path. If we can travel along a path and only it's like we're doing a road trip starting at A, and we visit town E, city B, town F, town C, town D, town G, and then we drive home to A. And it's just all in a straight line, A, E, B, F, C, D, G, A. And how a straight line works out is kind of in a circle or some sort of shape like this, okay? So D could have been drawn up here if you wanted, and it could be even a hexagon sort of circle-y shape, but you can see we can redraw that and still have all the same connections, that A is going to E, and then E goes along to B, then we drove to town F, then we went to C, then we went to D, got to G, our last stop on the road trip, and then we drove home to A. All right, so we've got that exact same path that we traced out with our mouse there. It's just here that's all been untangled and expanded out, so there's no crossovers, so that is a planar graph. So this horrible ugly mess here on the left was actually a planar graph, and by untangling it we've proven that, although it may not have been very easy to figure out how to do that answer at all. All right, now some shapes you need to think about that origami paper folding like we were talking about at the beginning of the lesson, and this one here, it all looks like a bunch of flat crisscrosses, but you can, I don't know whether you've got the 3D visualization to do it, but you can think of ECG as kind of this triangle flap of paper sticking up in the air on some origami shape. And what we can do is that particular shape with the D, we can kind of fold that over and fold it down towards the bottom of the page here. And if we kind of fold that over, what happens is a big mess, the way I've drawn it. But look, there's the original shape, and what's happened is C, instead of being up here, we've moved C right down here when we folded it over. D's still where it was, but when we fold over, the connection from E to C and G to C, you can see G to C and E to C have kind of stretched out this way, okay? So it was kind of folded up like that, and we folded it down flat. And if you check all your vertices, all your connections, that has all the connections. It doesn't have any crisscrossing, okay? And so that is a planar graph. That horrible mess there is a planar graph. So look, these things, you just work on them. Some you might get, some you might not get. You just have to do your best, okay? So there's 3 questions to do, pages 206 to 207. Now we've done some of them for you. This one here and this one here. I think we did that one. That should be an easy origami paper fold. B just folds up to there. That was a challenging one. This one's quite interesting. That's very interesting as well. Look, maybe just try and redo the whole lot from scratch. So even though we did those on the video, just look at them now and try and figure out how to do them yourselves. Do as many as you can. Just do your best. I know planar graphs are tough. I have troubles with them because I don't have great 3D spatial recognition. Some people have done origami though and stuff. I've seen students just look at these and just redraw them like some... you know, those people that do those really fast Rubik's YouTube videos, that's how they redraw them, because they can just sort of see it straight away. But some of us aren't so lucky and we can't do that. But just do your best. That's all I expect you to do. And I'll see you in the next lesson.